Hello, I'm Jerome, and today I will be explaining the integral and the limit of Riemann sums, which is defined on the integral from a to b of f of x dx, which satisfies the inequality L of f of p is less than or equal to the integral from a to b of f of x dx, which is less than or equal to uf of p for all partials p of the enclosed integral from a to b. This basically means that this basically means that the lower limit and the lower sum and the upper sum are squeezed together so that you could just get the sum in the middle, which is basically leading into Riemann sum. There's another way to do this though. Basically, take a partial p from x1, x2, so on, until you get to xn of a from the closed interval of a to b. Then you can set them up, break them up into subintervals from, which would basically be x of o, no, x0, x1, then comma, x1 to x2, and so on, to xn plus 1 to x of n. Then these will be of different lengths, which is delta x1, which will be the length from x0 to x of 1, delta x2, which will be the length from x1 to x of 2, and this will continue all the way up to delta x of n. To better understand, now you must choose a point that will be defined at the function. So basically, you would use f of x1, multiply that by delta x of 1 to define the point of x at x of 1. Then you would do it again for the value of x of 2, and you would continue until you get to f x n times delta xn. If you sum up all of these products together, you will receive Riemann sum, which says S of p equals f of x1 times delta x1 plus f of x2 times delta x2, so on and so on, plus so on and so on, until you get to f of x of n times delta xn, which again reevaluates the L of fp, which is less than or equal to S of p, which is less than or equal to uf of p, which just restates Darboch's method, but in simpler terms, so that you could just use, so you can find approximately, in the most precise way, Riemann sum, which is basically the middle between each integral, between each two distances, like such as x from xo to x of 1, the center of each one defined at that point, add them continuously up together, and you will get Riemann sum. Now for the first example, which is f of x, which will be defined. For our first example of Riemann sum, we shall use f of x is equal to x squared. X exists on the closed interval from 1 to 3. The p-values will be 1, 3 halves, 2, and 3. The value for x1 will be 5 fourths. For x2, it will be 7 fourths. x3 will be 5 halves. For delta x1 from x0 to x1, it will be 1 half. For delta x2, it will be 1 half. And for delta x3, it will be 1. Now, let's graph. First, we will notice that each separate one Each separate interval of P will be making a rectangle. The midpoints between the rectangles specified by the delta x will give us the values for 5/4, 7/4, and 5/2. Basically, to find S of P, you will get the value for 5 f, the value of f at 5/4 times 1/2, which is the delta x for 1, plus the value of the f value of 7/4 times 1/2, which is the x2 value, plus f of 5/2 times 1, which is the delta x3. So then the value of f 5/4 is 25/16 times 1/2, plus the value of f at 7/4 is 49/16 times 1/2, plus the value of f at 5/2 times the value of 1. Simplify this down, it will equal out to 137/16, which also is 8.5625. So now that we found the answer, we now know the sum of the sum between each value on the integral of the midpoints of f. It's not the midpoints, but the delta x values of the midpoints of each of the rectangles, which basically gives you the area of under the curve using Riemann sum. Thank you very much. Now for the second example, we will use the function of sine x. X exists on the closed interval from 0 to pi. The p-values will be 0, pi/3, 5 pi/9, and pi. x1 will equal to pi/6, x2 will be pi/2, x3 will equal 2 pi/3. Delta x1 will equal to pi/3, delta x2 will equal to 2 pi/9, and delta x3 will equal to 4 pi/9. Now that we know the values, we can calculate the Riemann sum, which will be the function evaluated at pi/6 times pi/3, the function evaluated at pi/2 times 2 pi/9, plus the function evaluated at 2 pi/3 times 4 pi/9. F at pi/6 will be 1/2, so it's 1/2 times pi/3. The f value pi/2 will be 1, so it's 1 times 2 pi/9, plus the f value for 2 pi/3 will be square root of 3 over 2 times 4 pi/9. That will simplify out to pi/6 is 2 pi/9 plus 2 square roots of 3 pi/9, which then simplifies to 3 pi over 18 plus 4 pi over 18 plus 4 square roots of 3 pi over 18. Simplify it out, and the final answer will be 7 pi plus 4 square roots of 3 times pi divided by 18, which equals out to 2.431. Now to evaluate the graph, which basically just restates the nodes of the x's and the delta x. And you can use the graph as a way to find the f value. The dotted lines explain where the x values will be at on the graph from the problem. Thank you. This has been an explanation of the limit of Riemann sums.